Good day, metric students, and welcome back to my third vertical discussion. And that is a national paper for metric class of 2023. And I'm going to expound number patterns on this particular paper of interest, which was question 2 and 3. At the broader scheme of sense, I had to be incredibly careful in my extractive approach to this paper. So let's do it together by peaceful means. Let's check what are we given. Question 2. We are given the arithmetic series, which is 7 plus 12 plus 17, and that is going to continue. So I'm going to pen question 2 here. I'm going to pen it down. So question 2.1, they are saying we are given 7 plus 12 plus 17 plus this is going to continue up until the nth term. Okay, so now they want us to find plus or minus few things given this situation. So 2.1, let's check what they want us to find. 2.1.1, determine the value of T91. So T91 is basically like a term number 91. So now you are going to say to yourself that Tn, because this situation, guys, is an arithmetic. So you're going to say that Tn is equals to a plus n take away 1 multiplied by the common difference between two consecutive terms. Now, what is your A? Your A is 7. And then what is your n? N is basically the position of the term, which in this case is 91. And then D is the common difference between two consecutive terms. So now I'm going to say to myself, T91 is going to be equals to A, where A is the first term of the pattern, which in this case is 7 plus n. N is going to be this value here of 91, take away 1, multiplied by the common difference between two successive terms, which in this case is going to be that difference, that is 12 minus 7, is going to give you 5. You can say 17 take away 12, it will still ties down and boil down to the same answer. So that is going to give you guys 7 plus this will be 90 multiplied by 5. And as a result, if you use calculator properly, you're going to get 257. Okay, you're going to get 257. So it's 7 plus 90 multiplied by 5. I'm getting something else here. It's 457. Okay, so this should be 457. So it's 7. Okay, let me redo it properly. 7 plus 91 minus 1 multiplied by 5. Oh, this should be minus here. I need to be very careful. So this is 457. Okay, so that gives me 457. Be very careful when you use a calculator here. Okay, so now let's check the next question, which is 2.1.2. They calculate the sum of 91 terms. So S91 is basically the sum of 91 terms. So when we talk about the sum, we're talking about the formula which behaves like this, like Sn, because it's arithmetic. Remember, there's a geometric. In this case, it's arithmetic. So I'm going to have n over 2. Remember, there are two formulas here. It's either you have the first term plus the last term. But in this case, you don't have the last term. So what are you going to use? You are going to use the one that is going to be applicable for this problem, which is 2a plus n take away 1 multiplied by the common difference. Now let's check. Do you have n? N, yes, you have it, is 91. Do you have a? A is 7. Do you have d? D is 5. So let's just substitute everything and get the answer here. So this is going to be s of 91 equaling to n. N is 91 over 2 into 2a. So your a here, your a is 7, and then plus 91 minus 1 times 5 for the common difference, and that is going to be 91 over 2 into 7 times 2 is possibly 14 plus let's say maybe it's 90 90 multiplied by 5, I'm getting 450 here. So that is 450, and then plus 14, and then you need to multiply this by 91 over 2. I'm getting 21,000, so it's 21,101 12, like that. Okay, so that is the sum of the first 91 terms. And then now the next question, they say to you guys, find 2.1.3. Okay, let's check that. Calculate the value of n for which Tn will be 517. So that is Tn equaling to 517. Okay, what is Tn? Tn is basically the general term, which we know that is a plus n minus 1 times d equaling to 517. Now, what is your a? Your a is the first term, which was 7 plus n. N is what you are looking for as per the question right here. Okay, so you basically have n minus 1 times d. D is still 5 equaling to 517. Let's just be very careful here. We have 7 plus 5n minus 5 is equals to 571. Therefore, that is going to be 5n plus this should be 2 equaling to 517. Therefore, 5n is going to be equals to 517, take away 2, you are going to get 515, and then now you have to divide both sides by 5, and then you're going to get n as 103. So that is the value of n. Okay, this wasn't really bad at all, and that's how you're going to answer 2.1.3. Now let's do 2.2 together. 2.2. What are they saying here in 2.2? The following information is given about a quadratic number pattern. So here we are switching from arithmetic to a quadratic. Okay. They say the first term, which is T1, is equals to 3. And then what else? You're also given that the difference between the first two terms, which is T2 take away T1, is going to give you guys 9. And the difference between the third and the second, which is T3 take away T2, is equals to 21. Okay, that you are given. Now, there's a 2 mark there sitting comfortably that you must accumulate in 2.2.1. What are they saying there? They are saying, show that the fifth term is equals to 111 or 111. How do you then do that? You have to analyze it in the stricter sense of the word. Check how. You are given that the first term of the quadratic pattern is what? That is 3. Now, you need to be very careful because they didn't give you the second term. Okay, they just gave you the difference between those terms. So let me say that here it's x because I don't know it, and then here it's y, and then here it's basically the fourth term, z. Okay, and then now what I'm looking for seemingly is T5. So here is going to be T5. I'm looking for that values. So I need to be very careful when I do this. There are many ways to do it. Let's check the easy one. They tell us that the difference between x and 3 is what? Is 9. That is given to us. Now, the difference between y and x, that is 21. But because this is a quadratic pattern, they were not stingy about that. So that means that the second difference here has to be common throughout. By that, I mean the difference between this one here, it is 12. Now, pay attention. It means that the difference between 21 and the term that comes after 21 is also 12. So now this tells us that we need to also get this term. But what I want to warn you is that in a quadratic pattern, the first difference is going to form a linear pattern. That means to get the term that comes here, we need to add 12 from 21, and that is going to give us 33. Okay, if we add 12 from 21 is going to give us 33. Now, be very careful because the difference between this term and the term that is here is still going to be constant here. Remember that here it has to be a constant. I mean, the second difference has to be constant. Okay, it must be the same. Now, it means if you guys want to get the term that comes after 33, you need to add 12 from this. It's going to give you the next term. So if you say 33 plus 12, you are going to get a 45. Okay, that's how you will try to analyze that. Why are we doing this? It's because now think about it. To get T5, it means you'll have to add these terms here. It's going to give you, but we don't have, X, Y, and the Z. How do you then do that? To do it, I don't think it's really that bad. It's not. How do you then do it? To get X, to get this X in a quadratic pattern, you add this one. You add those two terms, okay? So if you add 9 plus 3, it's going to give you 12, okay? And to get Y, you add these two. It's going to give you guys the third term. So 12 plus 21, you are going to get 33, okay? And then now it means to get Z, you will need to add these two in that order. So you're going to get 66 as a value. Now, to get T5, therefore, T5 is going to be equals to, the sum of, it has to be the sum of these three, in that order. So it's going to be 66 plus 3, plus 12. It has to be 12, the common difference, okay? So when you add these two, those three terms, it's going to give you T5. So that is going to be 111 if you add them properly. Let's verify that. 66 plus 33 plus 12, you get 111. The other way to get that value would be to say, let me just write OR here. Or to get T5, it will be the sum of these two. They will amount to that term. So it is basically saying 66 plus 33 is going to, let's check what you guys get. 66 plus 33. No, not 33. I mean to say it has to be, it's not 33. It has to be these two because they amount to the next term. Okay, so you say that it's 66 plus 45, and that is going to give you something. Just add it properly. So 66 plus 45, you guys are going to get 111 as well. So there are many ways to do this question. Actually, it wasn't really that bad. Now we have shown that we prove that T5 is equals to 111. Okay, now we need to get to the second question, 2.2.2. Show that the general term of the quadratic pattern is Tn equal to 6n squared minus 9n plus 6. So you need to prove that. What do you know? In a quadratic pattern, you know that the 2a is equals to the first term of the second difference. In this case was 12. Okay, so 2a is equals to that particular term there, and that is 12. Okay, you divide both sides by 2. So your a here is going to be equal to 6. Okay, and then now 3a plus b must be equal to the first term of the first difference. In this case is that 3. Okay, 3a plus b equals to the first term of the first difference, yes, which in this case what again is 9. So I'm going to put a 9 there. Therefore, 3 into A is 6 plus B is equals to 9. Therefore, B is equals to 9 minus 18 here. So that is going to give you guys 9. Now, to get C, so C will be, to say A plus B plus C must give us the first term. Okay, this must give us the first term of the pattern. So this equals to T1 of the quadratic pattern. What is A? A is 6 plus B is negative 9 plus C. What's the first term? So the first term here was 3. Okay, so you put 3 there. Therefore, C is equals to 3. This is going to be minus 3. So it's going to be 3 plus 3, and that is going to be 6. Okay, that is C. So now you say that therefore Tn is equals to an squared plus bn plus c. Remember, it's a quadratic, and then now you know what is a. So a is 6n squared plus b is minus 9n plus c. So c is 6. Okay, that's how you accumulate the first two question of 2.2. Okay. Let me just write it here. This is plus 6. Now, let's answer the next question, which is 2.2.3. They say to you guys, show that the pattern is increasing for all n, being natural numbers. So now, in this type of questions, it hangs students like a light bulb in most cases than not. In this case, you have Tn is equals to, n squared minus 9n plus 6. Like I said, students really bite the dust here. How? Think about it as a function. Okay, think about it as a function. In this case, a is positive, so this graph is going to really behave like this. What I want to explain about this type of graph, so that is your pattern. You are now taking it into the graph version of it. If you look at it in this way, that at this particular point here, that's where there's a change, in terms of decreasing and increasing. Allow me to write the axis of symmetry here. I just want to show you something quickly here. I'm just converting this concept into functions. Just going to make that one there. Now, this graph here is going to increase in that particular region. Okay, it's going to increase here. So what it means is in a literal sense. In a literal sense, at this point, Tn, the first derivative of the general term will be 0 at this particular space. Okay, so but now, which is the gradient? Tn, which is the gradient, is going to be 0 at that point. But the moment it leaves that point, it's going to increase. And then now, in this region here, it's going to decrease. So we are interested in what? In the increasing part. That means it's going to be in that region. So now, what do you want to prove here? You want to prove that the derivative is positive. It means increasing. If the derivative is increasing, think about it in this way. Like if the first derivative at x is bigger than 0, this means increasing in functions. And if you have the first derivative at x being less than 0, this means what? This means decreasing. Concurrently, if you have the f second derivative being bigger than 0, this means that the graph will be a concave up. Okay, and then now if you have that less than 0, it means the graph is going to be a concave down. it at a particular x value, and this x value is normally the point of inflation if you are to convert this concept into the cubic graphs. Okay, you are going to have the point of inflation right there. So but in this case we are talking about the gradient, which is the first derivative that is going to increase at that particular point. So my approach to this question will be that let me find the x value at that point, because it's going to give me the gradient the moment it leaves that particular point. So I'm going to say that n is equals to minus b over 2a. So now what is b from this situation? So b here is minus 9. When I have minus 9 there over 2a. What is a? A is 6. So if you really simplify this nicely, you might get 9 over 12. So 9 over 12 is possibly 3 over 4. Okay, 3 gets 3 times to 9 and 4 times to 12. So that is the value of n at that particular point. It's called the minimum point of this particular number pattern. But in this case, you want to prove that this is increasing for all values of n being natural numbers. Now, check my approach now. I'm going to say that therefore, t of n, the derivative at this point, but the point that I have is the axis of symmetry, which is 3 over 4. Okay, so I need to show that this value here is going to be positive. Okay, so let's find the derivative of this particular situation. How do you find that derivative? The derivative of that is going to be tn. Let me first find the derivative before anything else. Let me create space for this one. I'm just going to create space there and say, look, the derivative, which is tn of this, is going to be 12n minus 9. Also allow me to squeeze this part here to be that side. Okay, so that I can have more room to work in one page. So the derivative at this particular point is what? I'm going to substitute it now. Let's do it together. It's going to be 12 times n. N is 3 over 4 minus 9. That's going to give us 12 multiplied by 3 over 4 minus 9, which gives me 0. Wait a bit. Yes, it must give me 0 because that is going to be equal to 0. No, what it means is, yes, oh guys, sorry, my bad on this one, my bad. So what you must do here is to show that tn of this particular value here, which is 3 over 4, when you plug it back to the function itself, it must be positive, So let's plug this value here so that it must be positive in that region. So now if you do that, it's going to be 6 into 3 over 4. And then you square that minus 9. Let me reduce this particular space here. It's more like a calculus content, so be very careful. 3 over 4 plus 6. Okay, you guys will get something there. Let me check that. It's 6 into 3 over 4. It must be a positive value, actually. It must be a positive value. Wait, guys, I'm thinking about it in a different way now. I'm thinking about it in a different way. Yes, I'm thinking about it in this way. Sorry about that confusion. I'm thinking about it in this way. If we say something is increasing in calculus, we are basically saying that the first derivative, in this case, of that particular value of n, of n, but n in this case it's 3 over 4. This has to be positive. So now think about it in this way. Think about it in this way now, that the derivative itself, you have it as what? As 6n, or it should be 12. This should be 12n minus 9. That is the derivative. Now, if you wish to find the value of n here, it's going to be tn. It's going to be tn bigger than 0. And you solve for n from here, which is 12n minus 9. Oh, I'm messing up here because it's going to give me the same value here. So basically here, for increasing, oh, no wonder why it gave me 0. It's because we can't include 0 because it is stationary. At this point, it is stationary. Guys, sorry for this confusion. It's early in the morning and I'm not really sober. So now, if you guys check anything bigger than 3 over 4, anything bigger than 3 over 4, because that's when we are leaving this graph, it's going to increase. Okay, so it means now when you substitute a value of n into the first derivative, you won't take that one. You can take any value of n bigger than 0.75. Okay, so now tn, but the first derivative, I cannot use this value because at that point it is stationary. Okay, we can't use that point because that is at a stationary point, the turning point of it. So the moment it leaves the stationary point, that's when it's increasing. So this is 0.75. You can take 1, n of 1. You put it where? In the first derivative. It must give you a positive value. So it's going to be 12 into 1, minus 9. And if you do that nicely, it's going to give you a value here. Okay, let me put my tn. So my tn is 12n minus 9. Let me put it here. My tn is 12n minus 9. So that you guys see what's going on. So here the value is 12 minus 9. 12 minus 9 is 3. Okay, so that 3 is positive, which is bigger than 0. And it means what? Increasing in functions. Remember that in this space here is tn bigger than 0. And then this side is tn less than 0. So now if you substitute 12 into that first derivative, it must be positive. Okay, so now I'm going to say that therefore the pattern itself, the pattern is increasing for all values of n being natural numbers. Yes, sorry guys about that particular confusion there. It's more like a calculus analysis in my view, but otherwise you are more than allowed to comment and bring your view. I'm not allergic to views. You can comment. I love views. That's how I'm going to approach that question. But I know that you can also use some alternative thoughts here to complete the square and use your knowledge of algebra. It will still be increasing. Okay, I'm just going to use the calculus one because it's straightforward. Now, question 3. Question 3. How do you guys do this one? Question 3, you have 3.1, and that is given the geometric series, which is 3 plus 6 plus 12 plus this is going to go to n terms. So this goes to n terms. Okay. Now, it's a geometric series. And then 3.1.1. So what do you know about a geometric series? Is that you know that there's a constant ratio there. So let's have A being the first term, and that is 3. And then R is the ratio between two consecutive terms. In this case, it's 6 over 2, and that is 2. Okay, or 12 over 6 is 2. Yes, correct. Now they say determine the general term of this series. The general term would be Tn is equals to AR to the power n minus 1. Therefore, the general term is A is 3 here, and then multiply by the ratio. The ratio is 2 to the power n take out, n to the power n take away 1. That's the answer there. And then 3.2, oh, okay, 3.1.2. Calculate the value of k such that the sum of that geometric series is that one. It's 98301. The sum of that is 98301. So the sum from the index of 1 to k of 3 over 2, you have a ratio of 2 there to the power p is equals to 98301. So this, what it means is when you find the sum of these up until the kth terms, it's going to give you 98,301. Let's try and analyze that. Let's find the first few terms here. Okay, so if you take 1 and put it here, it's going to give you what? The first term of 3. If you take 2, remember from 1 to 2, 3, 4, up to the k. Okay, so now this is going to be p as 2 now. 3 over 2 multiplied by 2 squared. It's going to be giving you guys 6 plus, you take 3 now, so it's going to be 8 times 3 over 2, and that is 12. So this is going to continue to k terms. In this case, it's going to be k terms, and that equals to 98,301. Okay, so now let's try and analyze it in this way. We have our a, we have our ratio, we have n as k. In fact, I can pen it down for you that a here is 3, and then the ratio is still 2, but what changes now is n is k in our general formula. So our general formula is going to be Sn equaling to a. So because the ratio is bigger than 1, I'm going to say that is r to the power n minus 1. You divide this by r, take away 1. So therefore, the sum of this is 98,301, which is going to equal the first term, and that is 3 into 2 for the ratio to the power n. Our n is k minus 1. We divide this by r. Our r is 2 minus 1. Okay. So now you see that this is going to be 98,301 is equals to 2 take away 1 is 1. So you have 3 into 2 to the power k minus 1, like this. Okay. Let me, because I don't have enough space here, I'm just going to squeeze this. Okay. So now what can we do? We can divide both sides by 3. So we'll have 2 to the power k minus 1 is equals to, if we divide both sides by 2, by 3, it's 98,301. Divide this by 3. I'm getting a 32767. Then now you add 1 both sides. Let me say plus 1. I'm getting a 32768. Now I just need to apply the laws of indices. So you have to say factor of that. So it's that number factor, and then you put a 2 there. So 2 to the power 15, it gives me that very same number. So this is 2 to the power 15. You can use the logs. You can use the logarithm stuff. So k is equals to 15. This is the value of k that they were looking for. So here you can use the logarithm to solve this value of k. Remember, it's exponential. So exponential are primary logarithms in terms of the inverse. You can do that. You will still get k as 15. Okay, this wasn't really bad, you know. I think the complex one was the one of proving that it is increasing, you know. Yeah. but generally it was a doable paper, and it wasn't really complex compared to the one for last year. So are we done? No, we're not done. We are not done. So 3.2, what are they saying? A geometric sequence and an arithmetic sequence have the same first term, which is a. Okay. The common ratio. So let's talk about it in this way. This is the geometric series, the sequence, and the arithmetic sequence or progression. Let's have it in this way. The common ratio of the geometric series is it's 1/3. So here the geometric series, the ratio is 1/3. The common difference of the arithmetic sequence is 3. So D, this has to be D now. D is what? D is 3 for this situation. But what is A? A for both of them, it's A. They have the same value of A. Think about it. That is the first term. They have the same first term. Calculate the value of the first term. Okay. Now they say the sum of 22 terms of arithmetic sequence is 734 more than the sum of the sum to the infinite of the geometric series. So now we have to picture this properly. The sum of 22 terms, or the sum of the first 22 terms, is equal to 734 more than the sum to infinity of the geometric series. So more than means plus, of what? Of S15. Of S infinite. So basically here, the sum of the first 22 terms of the arithmetic sequence is equals to 734 more than the sum of the infinite geometric sequence. Now, let's do it together. This, if you want to picture it in an arithmetic series, is going to be n/2 into 2a plus n minus 1 times the difference is equals to 734 plus the sum of the infinite geometric series is what? That is the first term over 1, take away the common ratio between two successive terms. Now you will say that n is 22. So that is 22 over 2 into 2a. A you don't know it, so you're going to write 2a there, plus n. N is 22, take away 1, multiplied by the common difference between two consecutive terms. Possibly here is 3 that you are given. That is 3 there. Okay. Is equals to 734 plus that situation, which is a you don't know it for both of them, over 1 minus r of that, so it is 1/3. Okay, let's use algebra here. That is 11 here into 2a plus 22 minus 1 is 21. 21 times 3, you guys get 63 is equals to 734. That is 734 plus a over 1 take away 1/3. I think it's 1 take away 1/3, so it's 2/3. So that is 2/3. Okay. So now you can say to yourself, let me multiply everything by 11. You get 22a plus 63, times 11. I'm getting 6, 9. 3 is equals to 7, 3, 4. Plus, that is more like 3a over 2. If you simplify that situation, it's just the inverse of it. So it's 3a over 2, okay? Now, I think it's algebra. So you're going to say that is 22a minus 3a over 2 is equals to 7, 3, 4 minus 6, 9, 3. If I made a mistake, please comment on this one. So let's take out a as a common factor. So a will be 22 minus 3 over 2 is equals to 7, 3, 4 minus 6, 9, 3, which gives me 41. So let's check it again. 7, 3, 4 minus 6, 9, 3. Okay. Therefore, 22 minus 3 over 2, it gives me 41 over 2a is equals to 41. Is equals to 41 there. So now what do? I multiply both sides by 2 over 41. So a is equals to, a is equals to 1 over 2. So you multiply both sides by, let's just divide, because I see I'm a bit tired. 41 over 2 gives me 2. So I'm getting a as 2. Okay. Yeah, that's how you'll solve this particular paper for question 2 and 3. I think here my analysis will be that this question and this question was a little bit tricky to the students. They were not really bad, but a little bit tricky. But if you had practice, I think this will have been easy for you. Otherwise, guys, thank you for staying here up until we meet for functions, which is question 4 and question 5. And yeah, I'm gonna end at question 4 and 5, my next discussion, and then part 5 will be finance, your effective to nominal interest rate, and your interest rate, your future value, and the likes of the present value annuity, your balance outstanding. Okay, and then question 7, just the first principle calculus situation there that I will do for you. Question 7 and 8, I will do it, and 9.